Yeah. Good afternoon, everyone. I am audible to everyone. Am I audible?
Yes, sir.
Yeah.
Yes.
So today we are going to see polynomial division. So in the polynomial division, we are using Paravarthya Yojyat Sutra. Okay. Paravarthya Yojyat. So this is the sutra we are using. So what is the meaning of Paravarthya Yojyat in English? It is transpose and apply. Okay, transpose and apply. First thing, let us see why we are using in the polynomial division the Sutra Paravarthya. Why we are using this. So let me take one simple example so that you can get the idea behind this. Okay, suppose x square plus 3x plus 2 divided by x plus 2. Okay, in general, x plus 2 is a divisor and x square plus 3x plus 2. So our first step is the first term of the dividend, that is x cube, is divided by the first term of the, that means first term in highest degree term I am talking about from the left side. Okay, that is x. After that we are getting here x square term. So that is the first term of the coefficient. Okay, right. After that what we are doing, whatever coefficient term we are getting, that term is multiplying each and every term of the divisor and we are adding to the dividend. After that we are changing the sign because this is the division and we will continue the procedure. This is the division procedure. So x into x square, that is x square we are getting. After that 2 into x square, that will be 2x, sorry, I write it at 2x cube. So that is the reason it is x square. Actually it is not a x square. Okay, this is only x, right? So then we are getting x plus, right? After that, see here, we are changing the sign. This is the positive we have x square term, then it is become negative. Here also 2x term is become negative now. So after that we are solving the problem, cancel out these two terms, then we are getting here 1x plus 2. Okay, I'm not going to solve total problem. See, after multiplying divisor terms with coefficient digit, we are changing the sign. Whether it is a positive sign is there, then we are making into negative, sorry, negative into positive. So that is called Paravartya Yojya. In the division, we can use this formula because of one sign is changed into another sign. Why? Because we are in the division, we are using the subtraction concept. So are you getting the point why we are using Paravartya Sutra here? Is it clear? Is it clear why we are using Paravartya Yojya in the polynomial division?
Yes, sir.
Yes, sir.
Right. Now come to Vedic divisions for the Paravartya. Let me take few examples here so that you can easily understand. We will go through step by step just to follow the procedure. Initially, if you not understand, don't worry. I will take at least around 8 examples to discuss all the things. Okay, so be patient. The first question is x square, that is 2x square minus x plus 4. So it is the divisor. Okay, it is a divisor and the dividend will be here Okay, dividend will be 2x power 4 minus 5x cube plus 5x square plus 13x plus 16. Okay, the question is like this: 2x power 4 minus 5x power 3 plus 5x square plus 13x plus 16 divided by 2x square minus x plus 4. See how to use Paravarthya. Let us see now. Okay, I already told you, whenever we are getting the coefficient digit, this is the first coefficient digit we are getting in the dividend, and we have the terms like this. Whatever terms will be there, let us assume these are the terms. Each and every term, every time, these coefficient will be multiply each and every term of the divisor. Is it correct or not? After that, we are changing the sign here. So what I'm doing here, just I'm doing, first I will change the sign of these terms, then this will be minus 0, sorry, minus something, minus something, minus something. When I'm changing the signs of the divisor terms, then again there is a no need to change the sign again in the dividend part. Am I right? Are you getting my point? Once you change it, then every time there is a no need to change. So let me change it first of all only. Okay. So 2x square minus x plus 4 and the 2x power 4 minus 5x cube plus 5x square plus 13x plus 16. What I am doing here, just observe very carefully. I am changing the signs of the remaining terms except highest power degree. Why? Because this is the main divisor we call. Every time main divisor will be cancelled out. In this case, you can see every time we are cancelling this column. Am I right? That means it becomes 0. So there is a no need to change, especially this its sign. You can change the remaining signs. So what happened here? This is become plus x and this is become minus x. Once you change the sign, if you use the Paravarthya Sutra, every time there is a no need to change. Okay, right. Now see, when you are changing the signs of the terms of the divisor, then it is called modified divisors. What is called? Modified divisors. Okay, modified divisors. So modified divisors are now plus x minus 5. These are the modified divisors. So instead of taking the variables, what I'm doing now, I'm taking just the coefficients of the terms. Then we can easily calculate the problem. Okay, now here I'm writing the coefficient, that is 2 minus 5 plus 5 plus 13 plus 16, and here the modified divisors are, see, this is 1, this is minus 4. Okay, right. Now see, initially I will explain you each and every step very clearly. After that I will remove this box. Okay, initially I will explain you with box, after that I will remove that. So my main divisor will be here, this one, that is 2. We have to take, this is the main divisor. Okay, main divisor. So every time highest power degree coefficient act as a main divisor. It is clear my point to everyone? Yes or no? Is it clear? Right. The second step.
Yes, sir.
Now. Yeah, second step. In this second step, observe very carefully. How many modified divisors you have? How many digits? Here 1, here 2. So these two coefficients of the modified divisors indicates the quotient part and the remainder part. How? Start from the constant term, count 2 digits. Why? Because only 2 modified divisors we have. So that start from the constant. So this is 1, this is 2. After that, you draw the vertical line and separate the two parts. One will be indicates quotient part, another will be indicate remainder part. Is it clear my point? Is it clear?
Yes, sir.
Why modified divisors are indicating the remainder part and quotient part? Do you have any idea? Do you have any idea or not? Simply, I will tell you one reason. In the dividend, you have 2x power 4. And then divisor, you have 2x square. Isn't it correct or wrong? So that we are getting only x square. That means the quotient started with x square. So if you see, if you let us assume, suppose this is x square, next will be x, next will be constant. So this will be only our quotient value. So only 3 terms as indicates quotient part. So remaining 2 terms will be indicates the remainder part. That will be this thing. That is the reason we are separating. Why? Because already we are eliminating 2x square. Why? Because we are taking at a main divisor. Then we are left with only 2 terms. The 2 terms are simply indicates the remainder and quotient part. Is it clear for everyone?
Okay, sir.
Right. Now let us see the procedure first. So first we are dropping this 2 here. So when numbers entering into this box, that number must to be divided by 2. In case it is exactly divisible by 2, then write the quotient. What is the quotient? It is gone one time. Is it correct? Yes or no? One time. Now what we have to do? This one is multiplying modified divisors. That is 1 into 1. That is 1. We are writing to the below the -5. This is the next to place value. This is the next to place value. So 1 into -4, we are writing to the next to place. That is +5. That is -4 we are writing. Is it clear my point?
Yes, sir.
Now what is the sum here? -5, 1 that gives 4. Yes. So now 4 divided by 2 in this box. We have to do the division so that we are getting 2. Now these 2 again multiplying with modified divisors. Again the first modified divisor, if you see 1 into 2, that is 2 I am writing here. Okay. So 2 into -4, that is the next place value. So that it will be -8 I am writing to the next term coefficient below the coefficient value. So here if you see the sum, what happened? 5 minus 4 is 1. 1 plus 2, that is 3. Yeah, it is clear. I did correct or anything wrong?
-5 plus 1 gives us -4, right?
Oh, it is -4. Yeah. Then it is -4. Then what happened here? It also a -2. Okay,
-2.
this is also -2. Then what happened here? It is also -2, but this is the +2. Yeah, thanks for correcting. Okay, right.
Problem, sir.
So what happened here? 5 minus 6, that is -1. How much it is? -1. Okay, is it clear or wrong?
Clear, sir.
Clear,
Right.
sir.
Now see, now what happened here? 1 divided by 2, -1 divided 2, how much it is given? It is not exactly divisible. So when not exactly divisible by divisor, then you have to take it as it is. Okay, you have to take it as it is, so that it will be -1 by 2. It is clear? Anything is wrong in the calculation part? Okay, now see, -1 into this one, that is
Yes, sir.
-1 by 2. -1 by 2 into -4, that gives us +2. So I am writing here plus 2. So totally we are getting 18 here. Okay. And 13 plus 8, that is 21 minus 1 by 2. So that gives us how much? 41 by 2. So this is the 41 by 2. So now this is the x power 0 and this is x power 1. So that is 41 by 2x plus 18 is our quotient, and sorry, is our remainder part, and this is x power 0 and x power 1 and the x square. So that is x square minus 2x minus 1 by 2 is our quotient. Yeah, it is clear?
Yes, sir.
Yeah. Suppose let me take here another problem. 36x power 4 plus 15x square plus 3x plus 4 divided by 6x square minus 3x plus 2. So first write 36 and x cube term is missing. So that is the reason I am taking that is a 0. Next 15, next x value, next 4 value. Okay. Now main divisor, what is the main divisor? This is our main divisor. So that is our main divisor I am taking here. What is the modified divisors? This will be plus 3 and this one will be minus 2. These are the modified divisors. So only 2 modified divisors we have. So from the constant term you have to count 2 digits. After that you draw the line. So that is indicates the remainder part and quotient part. And another thing here, q value is missing, x square. Okay, everything is fine. Now see, first we are dropping 36. 36 divided by 6, that gives 6. Now 6 into 3, that is 18. And 6 into minus 2, that is minus 12. Now 18 I'm adding here, dropping here. So 8 divided by 6, that gives 3. So 3 into 3, that is 9. Okay. 3 into minus 2, that is minus 6. So that how much we are getting here? Totally 24 minus 2, that is 12. So divided by 6, that gives 2. Yeah. Yes, it is clear. Anything is wrong?
Clear, sir.
Right. Now 6 into 3, that is 6. And this will be minus 4. So this value will be cancelled out. These two also cancelled out, left with x. So this column indicates x power 0. And this will be x. So 3x is my remainder. And this will be x power 0 and x power 1 and x square. So that 6x square plus 3x plus 2 is my quotient. Is it clear?
Yes, sir.
Now see, now let me take here another one example. Suppose 8x cube plus 3x square plus 2x plus 4 divided by x minus 2. So 8, 3, 2, 4. My modified divisors is plus 2. So after that I will draw one line. Okay. Why? Because only one we have. So we know that we have the divisor here. The divisor is nothing but the coefficient of x only. Am I right? Is it clear? So before dropping 8, 8 must to be divided by the coefficient of x. Then it gives 8. So 8 into 2, that is 16. So totally 19. So before dropping the 19, you have to divide it by the 1. So then it is give 19. So 19 into 2, how much? 38. So now it is 40. 40, before writing 40, how to divide it by the coefficient of x, so that it gives 40. So 40 into 2, that is 42. So the, sorry, 80.
8.
So 80 plus 4, that is 84. So this will be our remainder. Our quotient will be 8x square plus 19x plus 40. Yeah, it is clear? Yes or no?
Yes, sir.
Right. So let me take here one more example. Ten x power 4 minus 3x cube plus 6x square minus 45x minus 22 divided by 5x square plus 6x plus 11. Okay, 11. So here 10, here it will be minus 3 plus 6 minus 45 minus 22. So remember, this is the main divisor, 5 will be. Okay, so now modify divisors minus 6 minus 11. Minus 6 minus 11. There are two modified divisors I have, so that after two terms we have to draw the vertical line. Okay, clear this one?
Yes, sir.
Yeah. Now see, before dropping 10, it must be divided by the main divisor. Yes or no? So that 10 divided by 5, that gives 2. Now 2 into minus 6, that is minus 12. So 2 into minus 11, that is minus 22. So now this is totally how much? Minus 15. So minus 15 is divided by the 5, then it gives how much? Minus 3. So minus 3 into 6, that is 18. Minus 3 into 20, sorry, 11, that is 33, positive 33. So if you add all these things, totally how much it become? This is 24 minus 22, only 2 we have. So 2 divided by 5, how much? 2 divided by 5. It is not exactly divisible. So we have to take as it is in the algebra divisions. So I am taking as it is. Okay. Now see, minus 6 into 2 by 5. That gives us minus 12 upon 5. Next, minus 11 into 2 by 5. That is minus 22 upon 5. Now let me solve these two things. How much this one? Minus?
Minus 12.
Minus 12 by 5. So this is 60, 72. So that is minus 72 by 5. Now come to this one. Minus 22 minus 22 by 5. Okay. Then how it is become? 10, 10, 110. 132 upon 5. So this will be minus 132 upon 5. So this will be x. Yes. So this will be our coefficient, and this one x and this one x square. So this is the quotient value. This is the remainder value. Is it clear? Any doubt?
No doubts.
No doubt. Now see another point. Let me discuss now another point. Very important point now we are going to discuss. This one, suppose can I take the same similar problem like this? Do you want any another problem like that? That's enough. Okay, let me take 2x power 5 minus x power 4 plus 5x cube plus 16x square minus 16x plus 36 divided by 2x square minus 3x plus 1. So let me write the quotients. 1, 9, 5 plus 16 minus 16 plus 36. So my main divisor will be 2. Okay, right. Now let me drop 2. So these 2 is divided by this value, isn't it? Then how much we are getting? 1. So my modified divisors will be plus 3 This one will be minus 1. So 1 into 3, 3. 1 into minus 1, that is minus 1. Next. Totally minus 6 I have now. Minus 6 divided by 2, that is minus 3. So minus 3 into 3, that is minus 9. Minus 3 into minus 1, that is plus 3. Okay. So now the sum will be how much here? Minus 5 we are getting. So minus 5 divided by 2 is minus 5 divided by 2 only. Why? Because it's not exactly divisible. So minus 5 into divided by 2 into 3. That gives us how much? Minus 15 divided by 2. And minus 5 divided by 2 into minus 1. That gives us plus 5 by 2. So what is that? Here sum. This will be 18 minus 15 by 2. So that gives us 36 minus 15 by 2. So totally how much we are getting? 23 upon 2. So this will be 23 upon 2. Now
21, I guess, sir.
Sorry?
21 by 2, right?
21 or 36? 20. Okay, 15 it is. Okay, right. It is 21. Yeah. This
Okay,
is
sir.
21. 36 minus 15, 21. Yeah. Right. 21 divided by 2. Now 21 divided by 2 into 3. That gives us how much?
63.
63 divided by 2. Right. 21 divided by 2 into minus 1. That is 21 divided by 2. Now we have to solve these two things. So let me write here. When exactly divisible by the divisor, then there is a no problem. Okay. Right. Minus 16 plus 5 by 2 plus 63 by 2. So that is minus 32 plus 5 plus 63 by 2. I did some mistake here. Sorry. What is that mistake, you know? Yes or no? Right. So this sum is totally 21 by 2. Isn't it? Correct or wrong? Yes. This 21 by 2, now it's going to divided by the main divisor so that it becomes 21 by 4. Now plus 63 by 4 minus 21 by 4. Okay. Now 16 plus 5 by 2 plus 63 by 4. So our LCM will be 4. So the minus 64 plus 10 plus 63. So you can see this one and this one. So totally minus 1 plus 10, that is 9 upon 4. So this will be 9 upon 4. Now plus 36 minus 21 upon 4. So that gives us 12, 14, 4 minus 21 by 4. So that gives us 1, 2, 3 by 4. That is 123 by 4. Okay. This will be x and this will be plus. So this is our remainder part. And this one will be our quotient. See, randomly I am taking. That is the reason problem become very complex. Okay, this is the quotient. Is it clear? Any doubt? After this, we will see how to solve these kind of problems in a single line. That will be the next topic. Okay. Is it clear?
Yes, sir.
Right. Now see, I will give one question for you. 4p square plus 2p plus 2 divided by 2p is given. In generally, how we are solving? 2p 4p square plus 2p plus 2. So first 2p we can take. So 2p if you are taking, then what is the value we are getting now? 4p square, isn't it? 4p square. So this will be cancelled out. So 2p I am getting. 2p by 2p, that is plus 1. So 2p again it will be cancelled out. Then we are getting 0. Then we are dropping 2. But we are finding the remainder. So that so 2 we are dividing with 2p. Then it will be 1 by p. So plus 1 by p we are getting. So that we are getting plus 2, then my remainder will be 0. So far, we are focused on only the remainder part. It is not a 0. That means in this case, it is exactly divisible. When you are coefficient taking like this. In the previous case, they are not divisible by exact. That is the reason we are getting some different type of remainders. So whenever you are trying to divide dividend by the divisor exactly, then this kind of negative or inverse terms will comes in the quotient part. Let me give the one example here. Same example, let me take 4p square plus 2p plus 2 divided by the 2p. Then 4 plus 2 and 2 I am writing. Let me take, this is the constant value becomes 0. So that is the reason, let me take it here 0 value. Okay, right. Now observe very carefully. 0 transpose modified divisor, and I have the 2p as a main divisor. Okay, main divisor, that will be 2 here. Remember that point. So now let me drop 4. 4 divided by 2, that is 2. So 2 into minus 0 you can take, positive 0 you can take. There is a no change. So let me take, okay, as per sign, let me write minus 0. So that I am getting 2. So 2 divided by 2, then how much I am getting? 1. So 1 into minus 0, minus 0. Okay, is it clear? Now we are writing here only 2 as a remainder part. In the remainder part, you are not dividing the remainders by the main divisor. So that is the reason you are not going to divide exactly. Suppose you want exactly what is the coefficient when remainder must be 0. In that case, what we have to do, I will tell you, remember that this point. Here we are getting 2. Don't stop the procedure. You continue the procedure. So I got 2 here. Again, these 2 value, these 2, again, I am dividing by the 2. I am dividing by the 2. So when I am dividing by the 2, then what happened? Then what happened? I am getting 1. Yes, I am getting 1. Is it clear my point or not? Is it clear or not?
Yes, sir.
Suppose I have 0. Let me assume here 0 I have. Okay. So this value into, if you multiply again, you are getting 0. This value into this value, if you multiply again, getting 0. Every time you are getting the zeros only. That means it is exactly divisible. But how to represent it? The main reason, the main important point, this one only. Whenever you are dividing the remainder part by the main divisors, those quotient digit you have to take in the form of the inverse. That means this will be x power 0 and this one will be x. Or I take here p variable. So let me take, this is p. So that is 2p plus 1 plus this will be p inverse. Next onwards. Why? Because you are dividing by the main divisors. That means it is 1 by p. So this is the my exactly quotient value. Okay. Let me take here another example to clear this concept. Suppose 8x cube plus 3x square plus 2x plus 4 divided by x minus 2. Okay, x minus 2. So 8, 3, 2, 4. Okay, right. Observe very carefully. Plus 2 I am taking modified divisor. Main divisor will be here 1. When main divisor is 1, there is no need to divide it. Because every time that value will come out. So I am dropping the line here. So first let me write 8. 8 into 2, that is 16. Then we are getting 19. So 19 into 2, that is 38. So we are getting 40. And the 40 plus 2. Sorry, into 2, that is 80. So 80 is gives how much it is gives? 84. So whenever you are dividing this part by the main divisors, you can put the zeros. Why? Because this is the decimal point. It indicates the decimal point. So 84 into 2. 84 into 2, that is 168. 168. Are you getting my point? Yes or no? Slowly you are
Yes, sir.
getting? Yeah. Now this part comes 180 divided by 1. Again 180, 68 we are getting. Again we are something getting. Again we are something getting. That means this will be x cube plus 19x square plus 40 plus 84 by p plus 168 by p square up to so on. Why? Because every time it will be increases but never decreases. That means it will be continuous, recurring. Is it clear my point?
Yes, sir.
Or no? Right. So now you fully understand how to do the polynomial division, yes or no? Why? Because now I'm going to use vertical crosswise in this method. That is the reason. Yes, clear or not? Right. How to
Yes.
use vertically crosswise? Vertically cross in Paravarthya Sutra for solving in a single line. Suppose x power 7 minus 2x power 5 plus 7, not 7, x cube plus 4x square minus 3 divided by x cube minus 1. X cube minus 1. Now the coefficient will be 1. 6 is missing, 6 term. So that is the reason 0. Then minus 2. 4 is missing. Yes, 4 is missing. So let me take that is a 0. Next one will be 1. After that 4. Next will be minus 3. Is it clear or not for everyone? Now, here if you look the divisor is nothing but x cube minus or plus x square plus 0x minus 1. That means 2 terms are missing here. So that is the reason 0, 0, minus 1. So we have the 3 terms in the modified divisor. So after 3 terms from the constant, we are drawing, draw the line that is indicates remainder part and the quotient part as usual. There is no doubt about it. Now see how to use a vertical crosswise here. So what is the main divisor? Can you tell me here? What is the main divisor? What is the main divisor? So main divisor 1. The highest degree coefficient is nothing but main divisor. So here main divisor is 1. So there is no need to take. Why? Because answer comes as it is. But let me take the initially let me write that one also so that you can easily understand. Okay. Now see how to use Paravarthya Sutra. I mean vertical crosswise here. Now see here 1, 2, 3. That means 3 digit we have. Okay. Right. After that, see this one. 1, 2, 3, 4. So 4 digit will come here. 1, 2, 3, and 4. This is nothing but 3 digit multiplied with 4 digit concept. This is the concept we are using here. Okay, right. So these dots are nothing but coefficients. These dots nothing but coefficients. So first let me drop this one. 1 divided by 1 is 1. So that means the first digit will be 1. Is it clear for everyone what I'm saying here? Yes, clear? Right. Whenever you drop 1, after onwards, you have to use vertical and crosswise combination. This is the first multiplication combination. As usual, whatever you are doing in the vertical crosswise, same procedure. So 0 and 1 we have. So this is the step we are multiplying. So totally we are getting how much here? 1. Yes, we are getting 0. So 0 plus 0, that is 0. So 0 divided by 1, that is 0. So my next digit will be this one. Now tell me, in the multiplication, whenever you complete the first step, then what is the second step? What is the second step? That is the 2-digit crisscross method. Am I right? Isn't it? So here it will be 2-digit crisscross method. So both are 0. So 0 plus this value, that gives us -2. -2 divided by 1, that gives -2. So here my new dot will be -2. Right. Now see, whenever you completed 2 combinations, then immediately you are taking 3 combination multiplication. 3-digit combination. So that is 0, 0, -1, 1, 0, -2. So that the 3-digit combination, how much we are getting here? Only -1. How much we are getting? Only -1 we are getting. So here -1 divided by 1, that gives 1 only. That gives 1 only. That means the another missing value will be 1 here. So totally 4 digit I got. Those 4 digit I am written as a multiplier. Now see, whenever you completed 3 digit into 3 digit, then what is the next step? Our next step will be again 3 digit only. Again 3 digit. That means 0, 0, -1. Next 3 digits. Next 3 digit you can see. Okay, after this, you have to take 2-digit combination. This one. If you not understand here, you can see here. After that, last multiplication, that is -1, 1. So that, right, now see what is the product here we are getting, everything will be 0. In this case, +2. In this case, -1. So, -1 or +1? Sorry, this is the -1, na? -1 divided by 1, that is -1. So let me write -s here. So then it is +1. Then it is also -1. Right. Now see, this value becomes 0. Now adding these two things, then we are getting how much? -2. Here it will be how much it will be? Tell me. 6, 1. So 1x square plus 6x minus 2 and this will be x cube plus 0x square minus 2x plus 1. So this will be our coefficient value, and this will be our remainder value. See, you don't focus on the calculations. Whether I did mistake or correct, you don't bother about it. But just you focus on the concept. Why? Because you have to apply on the remaining problem. So just to follow on the procedure only. Okay. So let me take here one more example. Okay. One more example. Suppose 4x power 4 plus 11x square plus 2x plus 12 divided by 2x square minus x plus 3. Okay, right. So I'm writing 4, cube value is missing 0, next x square, next x value, next 12. Okay, right. Now see. So my modified divisor will be here plus 1 minus 3. Then main divisor will be 2. After 2 digit or 2 terms, I am drawing the line. So first I am dropping the 4. 4 divided by 2, that gives 2. So look at here, 1, 3 bar. So I have 3 columns. So that means here we are getting 3 digit. This is nothing but 2 digit into 3 digit concept we are using here. So that first multiplication this into this only. But what is the first dot? First dot will be 2. So I'm writing 2. So here 1 and the 2. First dot will be 2. So multiply, you are getting 2 here. So after adding these two things, you are getting 2. You are getting 2 only. So 2 divided by 2, that is 1. That means the next dot will be 1. So after vertical multiplication, you are taking 2 digit combination, this one only. So 1, 3 bar is there, next to 2 digit combination, this one only. So that it is minus 6 plus 1, that is minus 5. So it means the total value will be here 6. 6 divided by 2, that is 3. Okay, that is 3. So that another missing value will be 3 here. So what is the next step here? Here next step will be this one. That means 1, 3 bar, 1, 3. And the next final step will be this one. So 3 bar and a 3. So that here it will be 0. Then after adding, you are getting 2 here. And this total value will be minus 9. And after adding these two things, you are getting 3 value. So this will be 2x plus 3. This is my remainder part. And x square plus x plus 3, it will be my coefficient part. Is it clear point? Yes or no for everyone? Yes, it is clear.
Yes, sir.
So how to do mentally now? So if you know the logic very well, we can solve it mentally also. Let me show you that. 2x power 4 minus 5x cube plus 5x square plus 10x plus 16 divided by 2x square minus x plus 4. Okay, now see, 1 bar, not 1 bar. Okay, 1, 4 bar are the modified divisors. So 2 minus 4 plus 5 plus 10 plus 16. Just you focus on the procedure. Why? Because I know I do mistakes in the calculations. Why? Because simultaneously I will teach you, even I am thinking in different ways also, but different matters. Everything will be running in my mind. So definitely I will do the mistakes. So just focus on the concept. If in case I did any mistake, so please inform me. Right. So what is the question here? This is the question, and the divisor will be 2. So first let me drop this value. So 2 divided by 1. Sorry, 2 divided by 2, 1. See, actually you can write here also. Okay, for you I am writing very clearly what will be run in my mind. So totally 3 digit will come. Okay, totally 3 digit will come. So first digit will be 1 here. Okay. So first in my mind, I will do 1 into 1. That is 1. I'm writing here. After that, I will drop 4. 4 divided by 2, that gives 2 only. That gives 2 only. So now 2 I got. So that means this is the 2. In the second step, it will be running like this in my mind. That means minus 4 plus 2. So that gives us minus 2. That means that equal to 3 here. Now immediately I write 3 here. Now see in the next pattern. So not 3. 3 divided by 2 means 3 by 2. Right. I will write here 3 by 2. Okay. Next step, it will be like this in my mind. That means minus 8 minus 3 by 2. That is 16 by 2. That means minus 13 by 2. So I will write minus 13 by 2. In the final step will be this one. That is minus 12 by 2. So that 20 minus 30. 20 minus 30. 20 minus 13. That is 7 by 2. Here it will be 32 minus 12. That means 20 by 2. 20 by 2. So that it will be x square plus 2x plus 3 by 2 is my quotient part. My remainder part will be 7 by 2x plus 20 by 2. Is it clear? See, totally I ignore the many steps here. By the single line I can solve by using vertical and crosswise. That is Urdhva Kriyak Vyam. Is it clear or not? Hello? Anybody is there? Hello?
Sir?
Is it clear or not?
Yes, sir, it's clear.
Right. Now let us see conventional mathematics versus Vedic maths. Right. Now see, let me take here simple example. Suppose 8x cube plus 3x square plus 2x plus 4 divided by x minus 2. So x minus 2, 8x cube plus 3x square plus 2x plus 4. Then we are getting here 8x square. So 8x cube minus 16x square. After that, I will change the sign and cancel out everything. Then I'm getting here how much? 19x square divided by this value means 19x I am getting. Let me drop this value also. So that 19x square, after that minus 38x. After changing the values, I got only 40x here plus 4. Again, I'm getting the new coefficient term that is constant as a 40. So 40x minus 80. So this will be minus and this will be plus, and the 84 is my remainder. Now come to the Vedic approach. 8 plus 3 plus 2 plus 4 and minus 2 is our modified divisor. First, let me write 8 here. After that, I am writing how much here? 16 plus 16. It will be the plus 16. Then I am getting 18, 19. Okay. 19 plus this value becomes how much? 38. So 40 I am getting. And here it will be 80. So 84 I am getting. By this example, I am not getting the idea, but because this is not suitable here. Okay, procedure will be same, but definitely I will tell you. See, let me take another example. Actually, it is not suitable. Okay, let me take here another one. Let a simple problem. Let me take. Yeah, 36x power 4 plus 15x square plus 3x plus 4 divided by 6x square plus 3x plus 2. So that is 6x square plus 3x plus 2 and 36x power 4 plus 0x cube plus 0, not 0. Next one will be 15x square plus 13, not 13, it is 3. 3x plus 4. Okay. First one will be, we can take x square. So 36x square. After that 18x cube. After that 12x square we are getting. So minus plus minus. So then we are getting 18 cube. After that 3x square we are getting. Then immediately we are getting here 3x. So that is 18x cube plus 9x square plus 2 6x. Here it will be 3x. So after changing the signs, we are getting minus 6 x square and it will be minus 3x plus 4. Okay. Is it clear? Yes or no?
Yes, sir.
Now, yeah, next one will be here. I did correct or anything wrong? Everything is going fine?
No, sir, actually, I think minus 18x cube.
Yeah, that is minus x. That is the reason I got. Yeah, thanks. So this is minus, minus, then it becomes minus. So everything will be changed here actually. Yeah, yeah, thank you. So this one will be minus and this one also minus. Then it is plus, it is also plus, and this one becomes plus. That is 12x square and this will be 9x. Then we are getting plus 2. Okay, plus 2 we are getting. So final value will be 4. So 12x square. After that, 6x plus 4. So minus minus minus. So 3x we are getting as a remainder. Now see in Vedic math, 36, 0, 15, 3, 4. Okay. And here it will be divisor will be 6. So then 3 and 2 bar. So first let me drop 36 here. So I'm getting 6. Okay, I'm getting 6. Now see 3 into 6, that will be 18. That will be 18. What is the thing I wrong here? Yeah, I did. This is the minus and this is also minus. Okay, right. So this is minus 18. So let me write here minus 18 divided by 6. That means minus 3. Okay. And it will be minus 12. Okay. Right. Now minus 3 into minus 3. That gives us 9 here. That gives how much? 9 here. And the next will be plus 6 we are getting. Okay. Plus 6 we are getting. After solving this column. So what I am getting here? 12 only. So 12 divided by 6, then I'm getting 2. So 2 into 6, minus 3, that is minus 6, and then it will be minus 4. Now observe very carefully. Unnecessary steps, what I'm saying? Unnecessary steps, we are writing in the conventional mathematics. Why? Because we know that the first term will be cancelled out. Isn't it clear? After that, the next column is very important. That is the reason we are writing this one. But there is a no need to solve this column at that time. Why? Because there is no use of it. See, look at now. So minus 18, I want to write. You can see here minus 18. After that, minus 12 is there. Minus 12 I retain. After that, minus this value is there. Then I am writing this value. But what we are doing, we are solving there to wasting our time. We know that this value is minus plus 3, but there is no need to write it. Unnecessary step, this one. Whenever you're solving third column, then you write the answer. Until that, there is no need to solve this one because we are not using a third column procedure. So you can see here, first the 3 value is there now. After the minus 6 is there now. After the plus 6, something will be there now. This is a total plus 6. You can see plus 6, and in this step we have the plus 6. So it is nothing but is a conventional procedure only. But we in which step, which column is important, but only we are solving in the Vedic approach. Is it clear, my point? Is it clear or not? Speak out, anybody. It is clear. Right. What is the difference between the Paravarthya and our vertical crosswise approach? See, 3 bar, 2 bar I taken. After that, I will write 6, 3 bar, and the 2. First multiplication, this one. Okay, that is minus 18. Is this correct? In the second step, I will take these two terms. That is minus 12 plus 9. That gives us minus 3 only. So instead of writing these two things, look at here, minus 12 plus 9 is nothing but minus 3. By using vertical crosswise, you will directly get minus 3 without this and this number. What is the next step? Let us see. The next step number will be this one, multiplication. That gives us minus 6 and a plus 6. Okay, minus 6 plus 6. If you solve the vertical crosswise, this value directly you are getting 0. There is no need to write these two things. You can write directly 0 if you use the vertical and crosswise. The final step, see this one. Directly I am getting minus 4. So everything is nothing came out from the conventional mathematics only. We have changed the small things and we are making it as easy. Is it clear? Yeah, thank you. Please participate in the poll because already I took 5 minutes more actually. We have the class now, another class on determinants. Come on. So in this way, if you solve any polynomial, either you can use Paravarthya or you can use vertical crosswise, or you can find the decimal answer. In the decimal means in the in the polynomial, it becomes inverse values. That means there comes in like a fractions. Still 3 members are there. Please participate in the poll. Only 66% is polled now so far. Okay, thank you. Ramesh sir, are you there? Take 2-3 minutes break. मैं रमेश सर को बुलाता हूँ. प्रॉब्लम क्या है कि सर अपन का क्लास में है लेकिन मेरे को नहीं दिख रहा है। एक्चुअली सर के पास थोड़ा प्रॉब्लम है, इसलिए मैं सर को बोला हूँ कि फिर से ज्वाइन होने के लिए। सर अभी 1 2 3 मिनट में ज्वाइन होता है, प्लीज वेट कर। कोई डाउट है तो पूछ सकते हैं आप रिलेटेड टू पॉलिनोमियल।
హలో
సార్ వినిపిస్తుంది వినిపిస్తుంది.
ఇది చూడు ఇక్కడ రాదు అని చెప్తున్నట్టే చెప్పేసారు. ఏం కాదు, మీ అబ్బాయి ఉంటాడు, హెల్ప్ తీసుకోవడం ఎట్లా అన్నాను.
సార్ నో ప్రాబ్లం, వినిపిస్తుంది వినిపిస్తుంది రమేష్ సార్. రైట్.
హలో
రమేష్ సార్
Hello?
వినిపిస్తుంది నాకు. సార్ వినిపిస్తుంది.
హలో
సార్ వినిపిస్తుంది.
మ్యూట్ ఉంది, అన్మ్యూట్ చేయాలి. హలో హలో చరణ్ లాల్, హలో హలో చరణ్ లాల్.
సార్ వినిపిస్తుంది. సార్
Hello, good evening to everybody. I am Dr. Ramesh Rao. I am speaking on 3 by 3 determinant. This 3 by 3 determinant is very useful in calculating the inverse of a matrix, in calculating the solutions of the equations, and this determinant is also used in various applications. In coordinate geometry also it is used. But initially we have to find the value of a determinant by common method first. That is, we expand determinant along a row or along column. Along a row, it can be expanded by 3 methods, and along column, you can expand it by 3 methods. The first method is Laplace expansion method. So first we will deal with 2 by 2 determinants. Suppose a matrix is given as ABCD, where ABC is the elements, then determinant of A is equal to AD minus BC. AD is the main diagonal and BC is the accessory diagonal. Okay. If you want to find determinant of 6 minus 3, 2 and 3, first we find the product of 6 and 3, that is 18. Then cross product, we get minus 6. That is minus of minus 6 will be plus 6. So if you add these cross products, you will get 24. So 24 determinant of a 2 by 2 matrix. Next slide. And determinant of 3, 2 and minus 4 and can also be found the same way. That is, find the product of the diagonals, that is 3 and 4, and subtract the product of the diagonal along 5 and 2 elements. That is minus of minus 5 and 2, that is plus 10. So the determinant will be 12 plus 10, that will be 22. Next. Determinant of a 3 by 3 matrix. And this is according to Laplace method of expansion. First, we'll take the first element, that is A1. If A1, B1, C1, A2, B2, C2, A3, B3, C3 are the 3 determinants, then determinant of this matrix is equal to A1 into B, A1 into B2 into C3 minus C2 into B3. Then next bracket will be minus A2 into B1 into C3 minus C1 into B3. And in the next bracket, it will be plus A3 into B1 into C2 minus C1 into B2. And this can be used for a numerical examination. Next slide. If you want to evaluate the determinant of a matrix minus 3, 2 and 1, 4, 1 and minus 2, 0, 3 and minus 4, we can expand this determinant along the first row. That is, you take the first element minus 3, and then take leaving the column and row of that element, you take the determinant of the 2 by 2 matrix of the remaining elements, and then you take minus of the next element 2, and take the next 2 by 2 determinants, that is leaving minus, this 2 is occurring along the second element is 2. You delete that row and column and take the remaining 4 elements and take the determinant of that matrix. And the third one will be minus 1 into 4 and 1 and 0 and 3. Now find the determinant of all these matrices, and then you add it, and you will be getting the determinant of that matrix as minus 50. Next slide. Next slide is by Sarras rule. So determinant can also be found by Sarras rule. If you want to find the determinant of Sarras rule, what you have to do is you put column 1 and column 2 elements along the determinant of the matrix. So you put column elements beside the determinant of this matrix, that is 2, 5, 1, and also the second column element, that is 4, 2, 4. Then you find the product of diagonals downwards, taking 3 elements as shown in the diagram. then find the product of the downward diagonal elements. And similarly, the product of the upward elements as shown in the diagram is found out. Now you take the difference of these two products, and that will be the determinant of this matrix. And Sarras rule is applied only for a 3 by 3 determinant matrices, and it cannot be applied for higher order matrices. Next example. Here also 2, 0, 3, 1, -2, 5, -1, 4, and 2. Along this one, you repeat the column 1 and column 2 elements, and then find out the determinant by Sarras rule. That is, the downward arrow elements, the product of the downward arrow elements are added to the product of the, and then subtracted from the product of the upward diagonal elements. The difference of these two products, some of these two products will be the determined by Sarras rule. Next. Now you can find the determinant of a 3 by 3 matrix by using Vedic method. In Vedic method, we will separate one column from the other two columns. Here, I am separating the first column from the other two rows of the elements. First row from the other two rows of elements. You can separate either a row or either a column. And here also you can find the different. You can find the determinant of a matrix by 6 method. That is either by separating the first column, second column, or third column, or by separating first row, second row, third row. Like that, you can find in 6 different ways. In this example, I am separating the first row from the other two rows, and then I am finding the determinant of the other two rows. 2, -3, -4 is separated from the other two rows. That is 5, 1, and -2, 10, 3, and -1. Then I am finding the determinant of 5, 1, 10, 10, 3. Then I am finding the determinant of the second determinant, that is 5, -2, 10, and 1, -1. And I'm finding third determinant, that is 1, -2, and 3, 1. Here you will get 3 determinants, that is 5, 15, and 5. Now, once you get this 3 determinants, that is 5, 15, and 5, you take the upper elements, that is 2, -3, 4. In the upper side, you change this, you will be adding the sign convention, that is plus, minus, plus. By adding the sign convention, and if you take the product crosswise, you will get the answer as 75. This is Vedic method. Next. Here also, in this matrix 2, 0, 3, 1, -2, and 5, -1, 4, and 2. Here also I am separating the first row from the other two rows, and then I am finding the determinant of the 1, 2, -2, 5, -1, 4, and 2. For this, from these 3 elements, I am calculating the determinant of 3 matrices. That is 1, -2 submatrix. That is 1, -2, -1, 4. And determinant of this is 2. 1, 5, -2. This determinant will be 7. -2, 5, 4, and 2. For this determinant will be 24. Now I am taking this upper row element, that is 2, 0, 3, and I am taking the determinants which I have found by 2 by 2 determinant, that is 2, 7, and 24, and I am applying the sign convention to the upper elements, that is plus, minus, and plus. Plus of +2 will be +2, minus of 0 will be minus 0 only, and plus of 3 will be 3 only. Now I'm finding the cross product of these 3 elements, and then when I take the cross product of the 3 elements, I'll be getting the answer as -42. This is the determinant of this matrix. Okay, next slide, please. Now, by vertically crosswise and Vilokna method also, you can find the determinant in a easier manner. That is, here the elements are 2, -3, 4, 5, 1, and -2, 10, and 3, -1. Now you take the middle element of this matrix, that is 1, and then you multiply 2 and 1. It is 2. 5 into -3, that is, we are taking cross product 5 into 3, -15. Here we will take the minus sign, so it will be minus into -15 will be +15. So 2 + 15 will be 17. That we will write the next matrix like that. And then -2 into -2 will be +6, and 1 into 4 will be 4. minus 6 plus 4 will be minus 2. That we will write there. And then later on, you take the reference of this 1 in the middle element, and then you find out the other two elements. That is 5 into 3 is 15, 10 into 1 is 10. 15 minus 10 is 5. Again, when you take the next determinant, that is 1 into 1 is minus 1, and 3 into 2 is minus 6. So minus 6 will be, because it is upward multiplication, it is minus 6 will become plus 6. So minus 1 plus 6 will be plus 5. So you will get 17 to 5, 5. And the middle element, that is 1, is divided by 1. 1 by 1, it will be 1 only. So 17 to 5 is 85. 5 into 2 is 10, that is minus 10. So you will be getting 75 as the determinant by below column. Okay, next slide. In this slide, it is 241, 503, 148. As in the previous, we have seen that we have divided the central element 1 by 1. Here also, if you divide 1 by 0, 1 by 0, division by 0 is not allowed. It is not possible. So what we will do is, we will exchange any two rows. That is, I will exchange 241 with 503. So when 50 goes upwards, and when we are interchanging these two rows, then the value of the determinant will change with its sign. So it will become minus. So central element 4 is divided by 1 by 4. So here, this rule is minus 1 by 4. Now, similarly, you find out the determinant. 5 into 4 is 20. 2 into 0 is 0. So it is 20. You write in the next determinant column, that is 20. Then with 0, with 4 reference, you write 0 into 1 is 0. 4 into 3 is minus 12. So 20 and minus 12, in the upper row, you will get two elements. And the downward row, what we have to do is 2 into 4 is 8. 1 into 4 is 4. 8 minus 4 is 4. So you are writing 4 there. Again, 4 into 8 is 32. 32 minus 4 is 28. That 28 we are writing in the second row of this second determinant here. Now, we use crosswise product of 20 and 28 and 4 and 12. 20 into 28 is 560. 4 into 12 is 48. But we are upward multiplication, we take a minus sign, so that becomes 48, plus 48. So 560 plus 48, and this divided by minus 1 by 4, you will get minus 150 as the determinant. This is the value of this determinant by below column. Thank you. And the opportunity has been given by Charan Lal. Actually, I was not interested to present this paper, but Charan Lal has requested me to present this paper, and because of Charan Lal, I am presenting this paper. I am not well versed with the presentation process. If any mistakes are there, please excuse me. Thank you, one and all. If you have any doubts, you can ask.
Sir, in the last example, why it is 1 by 4, sir?
20.
Just the last example which you took,
Ah.
where the
Yes,
center was
sir.
0 and we interchanged the rows and rows.
Yes.
Why it is minus 1 by 4? That is not understood, sir. Please
Why
explain. that,
why minus 1 by 4? See,
Okay.
Yes.
whenever
What is,
if we change any two rows of a
73?
determinant, whenever we change any two rows of a determinant,
Yes, sir.
What comes after
this
59?
determinant will become negative. So I have taken the minus sign. Since we have to divide the middle element 4 by
Very good. What comes after 99?
this one minus 1 by 4, that's why we are dividing by. Suppose if we divide by 0 by 4,
What comes before 2?
Yes, sir. We have changed in the second here, sir. We have changed the rows. This is
What
understood,
rows,
sir.
that's why determinant will become negative. And because of that, we are able to divide 1 by 4.
Very good.
Otherwise,
What
0
comes
by-
before 9? Very good. What comes
madam. See,
before 50?
in this in
1
fine art
by
3, we
50.
cannot 1 by 0 is not allowed. Is it clear? In the original example, 241, 503, 143, when you take the middle element 0 and if you divide by 1 by 0, that 1 by 0 is not allowed in division process. Hence, I have changed the rows. When I change the two rows, the value of determinant will become negative. So minus. When I change the rows, I am getting 4 in the middle. So that's why I am dividing this minus 1 by 4. Is this clear?
Okay, sir. Got it, sir.
Okay. Any other doubt?
Yes, sir. Doubt clear, sir.
So please participate in the poll. Thank you so much, Ramesh sir.
Thank you, sir. This credit goes to you. If you have not encouraged me, I would have not presented this paper.